I feel like the atmosphere is really electric. I mean, listen to it right now, and this is the last day of the show.
Well, it's a great chance for us to gather new business and see what's new in the industry.
See you at the next IT Expo. We'll be here.
Hi, everyone. Good morning. So I'm really excited to be here today. My name is Diane Chaleff, and I am from Google Cloud's Office of the CTO. I am also from New York City, and right before coming on stage, I decided to check the weather. It is currently 6 degrees, and it feels like it's minus 11. So this is an especially great day to get to be here with all of you, not only to talk about amazing technology, but also to escape the cold for a little bit. So today's talk is going to be about machine learning and team communication. This is a topic I've spent a lot of time working on, and I have lots of thoughts about it. In the next 30 minutes, I'm going to try to get the thoughts that are in my head into all of your heads. This is the goal of presentations, for the speaker to transfer her idea to the audience. The notion of trying to get what's in my head into all of your heads is something that we like to call capturing and conveying thought. And really, it's what the entire team communication market is based on, trying to capture and convey thought more effectively. So how do we measure more effectively? At Google, we are obsessed with data and measurement. And so back in April 2015, we did a study that looked at how time was spent at work. The most valuable thing you do at work is ideation. The other work you do, task management, cleanup, analysis, these are all support functions to ideation. The faster we can get through the other tasks, the more time we can spend on ideation, which is what creates your business differentiation. Ideas, truly great, unique ideas, are at the core of your business. So what % of time do we think is spent on idea generation? And this is going to require audience participation. So by show of hands, who thinks the answer is A? Good job. You guys all think you spend some time ideating. B? Few hands. C? Few more hands. And D? All right, kind of evenly split. So the correct answer here is B. It's just 5%. 95% of time is spent on overhead. Overhead isn't generating new ideas. It's mundane, repeatable busy work. 15% of time is spent on formatting and layout. 20% of time is spent on task tracking. We should be able to reduce this time spent. And part of this reduction is cultural, which I'll come back to. And part of it is having the computer or the machines do more of it for you. Having the computer do work, most simplistically, is discussed in terms of saving time. In each example I will talk through, this will be true. The computer makes it faster to do the same task. Saving time is a super important measure. Time is the only resource we can't buy. And for me, at least, it continues to be a struggle to find enough time in the day to do everything I need to get done. So anything that can help me save time is always a win. These improvements from machine learning, though, in addition to saving time, provide other, often even more outsized benefits. One of these is preventing distraction. Did you know that on average, every 3 minutes, a typical office worker is distracted? And once distracted, it takes 20 or 30 minutes to regain focus. So how can machine learning limit distraction, thereby saving time? Well, it can help by predicting what file you want to open next, based on a number of factors. Things like what you've looked at recently, what teammates are working on, what's on your calendar, what's actively being discussed over email, and others. It's much faster than navigating by using traditional methods like searching or clicking through folder hierarchies because the information is right there in front of you on the opening page. The time savings here is significant, especially at Google scale. We've calculated just by predicting the file that you're looking to open and not needing to search or click through a folder hierarchy, we save every day 850 work weeks or 34,000 hours with all of our users around the world. In addition to predicting the file you need, machine learning can go one step further. It suggests what action you want to take on that file, saving time from scrolling through the document and figuring out what was it exactly that I wanted to get done. But even more important is that it prevented you from being sidetracked into something else. You didn't click on some random file that came up in search or that you found while navigating a folder hierarchy. You didn't waste 5 minutes being sidetracked, working non-linearly, and then more time trying to regain focus. You focused on the task at hand in the moment it was needed and got it done. And at least for me, I'll take advantage of just about anything that stops me from distracting myself. We know that flow is hard to achieve, and while there are many theories about what we can do to create flow, we know that distraction is one of the fastest ways to break it. So in this case, by predicting the file you need, we've removed the opportunity for distraction. Machine learning made it faster, and machine learning got rid of distraction, something that comes up far too often in our day. Another key opportunity for machine learning is identifying when it's sufficient. For most of us, the work we do isn't as black and white as a high school math problem. How do you decide how much time to spend on a project? When is it good enough? There are many things we can work on or that we can make better, but spending more time on those items means that we can't move on to other tasks. Our day is spent making trade-offs. And because we care about the people around us, we often take extra care in our communications. Let's take a look at the following example. You open an email, it's long and it's poignant. Your colleague, employee, or partner did such a good job, and you want to express that in your reply. And your brain says, they sent me such a long email. This email is going to require a long reply. But here's where machine learning kicks in. Sure, machine learning can help you type faster, and Gmail does this with a feature called Smart Compose by proposing phrases such as, looking forward to our meeting next week, so that you can tab ahead to the next thought. This definitely saves time. But there are other advancements in type communication that reframe how much do I need to say. Gmail released Smart Reply, which, based on machine learning, proposes a reply usually of a couple words in length, saving the 10 or so keystrokes necessary to type it out. But it also does something far more important. It breaks down that daunting question of how much do I need to say by offering simpler options that perhaps your brain didn't initially think about. Your mind now realizes, hey, you know what? They're actually just looking for a looks good in the response. Instead of feeling overwhelmed by the need to reply and putting it off till later, or spending 10 minutes to craft a paragraph response, you've simplified what needed to happen to get the task done. You've realized that the less wordy alternatives are perfectly appropriate for this particular case. This is machine learning offering an alternate perspective. You don't need to take it, but it is this alternate perspective that helps us realize that perhaps the initial way we were thinking about doing something might not be the best way to proceed here. Another way machine learning helps us is reminding us when we forget to do something. No matter how hard I try, I somehow forget to do things, especially when it comes to email. I'm human, and occasionally things fall through the cracks. In this case, machine learning is magical. It's prompting me to do something that completely slipped my mind. With a feature like Nudge in Gmail, things I forgot to follow up on are prompted in a subtle way. It's not creating a new task or something extra to think about. Checking my email is a natural part of my day. Instead, it's saying, hey, looks like you might have missed this note. It's not a distraction. It's helping me directly in my comfortable workflow. And here's another example I want to talk through. I want to talk about meetings. While I'm excited to attend a good meeting, booking the meeting, in my opinion, is often not a fun task. Finding a time that works for everyone is difficult enough. We are all busy. But what really bothers me is booking a conference room. I finally found a time that works for our whole group, but now I'm sorting through a system to select a conference room. And what's worse, what about when I can't find a conference room at that time? From research Google has done, I know that 40% of booked conference rooms end up going unused. So I found my time, I'm ready to book my meeting space. I can't find a meeting room. I delay my meeting, and actually, 40% of the time, a conference room will be free during the original time I wanted to meet. This is pretty frustrating. So now, let's let the machines remove some of that frustration for me. Machine learning, based on inputs like where people sit and their calendars, can both suggest a time that's good for everyone to meet, but can also take care of booking the meeting room. For picking a room, people usually care about two things. Is it big enough to seat everyone? And, given the rooms available, is it the closest one to me? In addition to recommending the initial room, machine learning can continue to optimize rooms in the background. If people decline the meeting invite, it can switch from the room that may have originally seated 10 to a room that seats 6. If people join the meeting, it can size the room up. Room booking should not even be a concern. Obviously, I'm saving time booking the meeting because I don't have to rebook it several times as the invite list changes. But more importantly, the unnecessary mental frustration of selecting a meeting room has gone away. Okay, so now we're in the meeting. Some of us are in the same place, and some of us are over the video conference call. In any normal conversation, there are hiccups around whose turn it is to speak, but these end up exacerbated when we aren't all in the same physical space together. We waste time asking for people to repeat themselves when they're static on the line or when we talk over each other. The time wasted is one aspect, but the other frustration is that the conversation isn't smooth. It's hard to get into a rhythm. Machine learning helps the conversation that would naturally take place if we were all together flow in a similar way. It can do things like block out unwanted sounds. It can make adjustments to video and audio quality based on participant bandwidth. It can also go one step further. Small cues we give with our hands, our heads, our bodies show when we are about to speak. Machine learning, through all of the examples it sees, can identify these movements and prepare to zoom in on a face or turn a microphone louder. In all of these cases, machine learning both save time from asking people to repeat themselves and improve the rhythm of the meeting. And for one final example in this section, let's talk about bots. Bots are like virtual teammates. They bring information into the conversation from other places and take action right then and there, saving valuable time. They bring context into the conversation so that all of your team's work is in one place. In addition to the time savings, they help the team be organized and get done the little yet important things that are too easily distracting and historically time-consuming. So let's take a moment to recap where we are. We talked about how machine learning makes it faster to find items we need, but more importantly, it makes sure that we don't get distracted along the way. We talked about how machine learning provides a new perspective to help us write an email a little bit faster, but that might be just as effective, or reminding us that we accidentally forgot to do something. We talked about how machine learning means we can have our meeting now instead of in 2 weeks from now, because we can better manage our conference room resources. We have good flow in our meeting because machine learning improves the video and audio quality, both through optimizing bandwidth and by responding to subtle visual cues. And we also talked about bots and how they are like virtual teammates. So one question you might be asking yourself is, why is machine learning needed? Why can't a human code up an algorithm to do all of this? An algorithm designed by humans would either, one, do a systematic search through possibilities, that's how game-playing algorithms work, or two, run through rules that capture the mechanics of the domain. That's how expert systems work. The biggest problem with these approaches is that they are brittle. They only work on the scenarios you've anticipated. If the system encounters something unexpected, you're out of luck. The second problem is knowledge engineering. A huge amount of manual effort is required to author all of the scenarios and rules to capture the ins and outs of all the possible situations. If the world changes, you have to edit and re-author the rules. This is sometimes called knowledge maintenance. With machine learning, you let the system learn the rules or search possibilities on its own. The downside of this is that you need a lot of data. You need examples of all the possible situations the system would need to deal with. But if you have the data, the system can figure out the algorithm, representations, and rules on its own. And it can do so in a generalized way. So it not only handles the examples you gave it, but generalizes to new, unseen, unexpected situations. So we've talked about why machine learning is needed, but another point I made is that these items I discussed are located in different applications. Why am I not standing up here talking about some super tool that does it all? Well, that's because I don't think that that's a good product direction for a few reasons. In 1982, Alan Perlis coined the phrase, "Beware of the Turing tar pit," in which everything is possible, but nothing of interest is easy. Why am I referencing a phrase more than 30 years old to talk about technology? We've advanced so much since then. Well, it's because I agree with what he says. Something that promises to be able to do everything probably can't do anything well. Sure, maybe it can do everything, but because it's trying to be all things at once, the simple item you are trying to accomplish is suddenly so much harder than it needs to be. In The Design of Everyday Things, a personal favorite of mine, if you haven't read it, great book, Don Norman explains that devices where one button leads to one action and only one action are much easier to use. He uses the analogy of a complicated phone system where functionality is buried under functionality and it's hard to even know it's there. Because of these design principles, specialization in an application is far more user-friendly than something that tries to do too much. Use cases are broken down into problems and solutions, and these applications need to make sure they're doing a great job at the problems and the solutions they prioritize. The more problems and solutions that they try to offer, the more that trade-offs must be made between them. and the worse each use case becomes. There's a second reason for this specialization beyond user experience. Monolithic applications are hard to build and maintain. It's much faster to improve upon and maintain smaller applications than larger ones. In addition, for the people in charge of building them, they can't be experts on everything. So making an application super large fundamentally means that the seams will show. People will know their area, other areas will appear glued on, creating a terrible user experience. The trend we've seen is that applications bloat and then they split. Facebook split Messenger out of its core product, and Google made video and chat separate tools. This allows each application to optimize its user experience for the specific use cases it's addressing. So, what does all of this mean for you? How do you adjust strategy and product design to meet the needs of team collaboration? As we discussed, there are several ways that machine learning both saves users time as well as alleviates frustration, distraction, and communication mishaps. As you look for products to meet your team's needs, expand your requirements to include technologies investing in machine learning. Furthermore, as we discussed, users will continue to appreciate the specialization in an application over one with many functions because those applications will be more user-friendly. With advancements in IDaaS, the IT overhead of running multiple applications will decrease, and your users will appreciate just how great each application is at what it's designed to do. Be sure to choose solutions that facilitate team collaboration, both in technology and culture. As you look at technology products, in addition to being focused on what makes individuals productive, evaluate equally, if not more so, if they are making teams productive. Make sure you design workflows and policies that bring out the best in both teams and individuals. The tools you pick to use and the ways you leverage them influence culture and can encourage inclusiveness and teaming. Good technology will foster the culture of collaboration that we all want to see in our workplaces. Thank you very much.